Hello students, welcome back. Bot Bash Arena is coming out really nicely. We've got a neat little robot that we can move all around our arena that we've created. Our weapon system is working where we can aim our projectiles, and we have this heat system in place that can ramp up our rate of fire, but we have to be careful. We have to leverage that system correctly. Otherwise, we'll get too hot and we'll shut down our system as it needs to cool. So that whole gameplay is working, and it's working well. There's just one big problem. Right now, our game will run really slow on slow computers, and it will run really fast on fast computers. And this is because our game is written around all of our operations being based around frames per second. How many frames our computer can process. If you remember, like the draw function, we said it runs every single frame of our game. And we even assumed that we were running at 60 frames per second. So that means the draw function, which is updating our player, our bullets, our weapon systems, our heat systems, those are all updating 60 times a second. But what if our computer is slow? What if it's only updating, what if it only runs at 20 frames per second? Well, now those systems will only get updated 20 times a second, and gameplay will be slower. On slow computers, our game runs slow. On fast computers, our game runs fast. And those inconsistencies are not good for us. We want our game to run at the same rate no matter how fast our computer is or how slow it is. And so what we need to do is we need to switch from a frame-based system, which is where we currently are, to a time-based system. Because on a slow computer, on a fast computer, or on a computer that is just right in the middle, a half a second is a half a second is a half a second. Time is always going to be experienced the same. So step one here is to switch from a frame-based to a time-based system for our games. Once we have that time, we're going to use it to create something known as a difficulty ramp. When we start our game should begin pretty easy. And the longer we play it, as time goes on, the difficulty of our game is going to increase and increase and increase and increase up to some maximum difficulty. So we'll create something known as a ramp to ramp up our difficulty values. And this will all be based on how long we've been playing the game. So it brings back time. So let's head to our computer screen and let's dive into this lesson on delta time and difficulty ramps. I have lesson 5's starter file open right here in vscode.dev. I'm going to minimize my browser though and open this file directly so I can see what I have to work with. All right, so here is lesson 5's starter file. So let's see, at the beginning of this file, we've got lesson 5. Okay. It looks like I've got some information in the HUD now. In this bottom HUD, our system uptime, which is just reading 0 seconds. So clearly we're not tracking time correctly. If I try to fire, well, okay, my fire system's not working. My heat level, it says NAN, which stands for not a number. So I don't know what the heck is going on there. Whoa, and my movement system is completely busted too. I'm zooming all over the screen here. So it looks like my movement system's broken, my weapon system is broken, my heat system is broken. All of these systems that were once frame-based, we are now going to have to switch them to be time-based in order to fix them again. So let's head over to our computer screen and we'll dive right in. Mission number 1 says add the delta time variable and clamp it. All right, so we got to actually implement our time into our program. So let's go look. We're calling it delta time. So mission number 1. What exactly is the delta time variable? Well, the delta time variable is the amount of milliseconds, or 1/1000th of a second that has occurred since the last frame was processed. So a frame happens, and then we start timing, and then when the next frame happens, we stop timing. And the number of milliseconds that has elapsed gets stored in this variable called delta time. Now, we got to make sure that we use this delta time variable. Right now, we're trying to access it here called dt, but right now we have it set to 1. Well, that's not right. So what we're going to do is we're going to set it to the delta time variable. So now we know how many milliseconds has elapsed since the last frame. And remember, this is getting called every frame of our game. This is that P5 draw function. But this is milliseconds. I don't like milliseconds. I want seconds. So to get seconds, I'm going to divide by 1,000. All right, so now I have how much time has elapsed since the last frame of our game. But there's just one problem here. If delta time gets to be like super big, this value could spike, and that could cause some weird gameplay, operations. Like imagine I'm playing my game, and we're tracking how much time has happened since the last frame, and then I leave this tab. So like 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds goes on. That's like 5,000 milliseconds. So that would be 5 whole seconds. And I come back, that huge amount of time that has elapsed could cause some weird behavior in our game. So we don't want that to happen. So what we're going to do is we're going to set the largest possible value we can have for our DT variable. And the way we set the largest possible value is taking the min function. So this is weird. I always find this kind of hard to wrap my head around. We're going to use the min function to get a minimum value out of two values, and that will set the largest possible value for our DT variable. So I'm going to say, hey, pick the smallest out of these two numbers, 0.033 or delta time divided by 1,000, right? So if this is like 5, well then dt, what's the minimum value between 0.0033 and 5? It's going to be 0.033. So if I'm playing and I go off my tab and I wait 5 seconds and I go back, dt is not going to spike to 5. It's going to take this smallest value of 0.033. Awesome. So now I have this delta time, dt, the amount of time that has elapsed since my last frame. And that time interval is the same on every computer, right? So time is time is time. How we experience that time, whether it's a fast computer or a slow computer, is going to be the same. So now let's head to mission number 2. Mission number 2 says, well, we got to use that time now. So if our current game mode is equal to play, we are going to update the runtime using our delta time variable. And we're going to pass our DT variable into update functions that require time-based behavior. Okay, so it looks like we got a variable called runtime seconds. Let's just go look. Is this one of our gameplay variables? So in our gameplay variable region, yep, we get runtime seconds right here. So runtime seconds. We initialize it to 0. And I'm thinking runtime seconds is probably going to be the variable that holds our system uptime that we're showing here in the HUD. So we want to update this. It says update runtime using delta time. Well, right now we're adding 0 to it every time the draw function runs. Well, that's silly. So I don't know. What do we want to add to it? Let's add 1 to it. How's that sound? So let's add 1 to it every time it runs. Whoa! Our system time is going crazy. Have I been playing this game for 300 seconds? Or, have I been playing it for 500 seconds? Absolutely not. I have not. So our time measurement is not correct here. Well, what's going on? Well, if you think about it, this draw function runs every single frame of the game. So every single frame, I am adding 1 to runtime seconds. So what this is not tracking the amount of seconds that has elapsed. This is tracking the number of frames that have elapsed since I started the game. So right now I have created, like 1,500 frames. I don't want that. Instead, I want the time that has elapsed since all of those frames have been created. And the time here is going to be given through our DT variable, right? Remember, delta time is the amount of time that has elapsed in milliseconds since the last frame. And so DT, we just clamp it, make sure it's going to be a safe value. We're going to add that DT, and we'll keep track of that time. So now if I refresh my page, I should get an accurate representation of time. And that is much better, right? 5 seconds, 7 seconds. That is accurate. And so now we are keeping track of our time interval correctly. So right now, like our game has been running for 11 seconds, 12 seconds. And if I come over here, and I come back over here, you can see it didn't spike up. So it's keeping track of the time being played correctly. So that is really, really good. But there's a second thing we got to do here in this mission. We got to pass DT into the update functions that require time-based behavior, because we saw a bunch of these systems are now broken. So it looks like we have a new function in here that we're calling update ramp values. We mentioned we have to build a difficulty ramp. We're going to update it. But then we have update player, update weapon system, update bullets, and update heat system. I think every single one of those systems is busted. So we probably got to give them access to our new time that we just created. Let's go take a look at our functions. So there's update ramp. Ooh, we got some missions in there we got to do. Update player. It needs that time. So we got to give that DT. Update weapon system. It needs that time, DT. So we got to give that our DT. All right. Update bullets. It needs that DT. So we got to pass that in. Update heat system. It needs DT. So we got to pass that into all of those functions. So let's come back up here into mission number 2. We've calculated the delta time variable DT, and we're going to pass it into update player. We're going to pass it into update weapon systems. We're going to pass it into update bullets, and we're going to pass it into update heat systems. So now all of those systems have access to that time. We're switching over to a time-based system. Each of those functions now have access to it. My movement system is still broken. My heat system seems to be a little bit better now. Now it says 0. And can I fire? I still can't. Oh, I'm firing. The bullets are flashing on the screen. Are they flashing on the screen? Or is it just that they're moving? I think they're just moving extremely fast. So it looks like our heat system is operational. I'm building up heat. So that's good. Let's just see if it works correctly. So giving the time to the heat system, heat's back online. So our heat system is working, but our fire system and movement system are still completely busted. So let's go look at what mission 3 has. Mission 3 puts us in the update player function. So inside update player, we now have access to this time interval, DT. We have to apply delta time to player movement. This is going to ensure that movement is consistent across all of our different frame rates. So what are we doing right now? Well, it says player.x plus equals move direction.dx times player speed. Okay, remember we got move direction. Move direction was from our get input direction function. So if I look here, get input direction, we have dx and dy. They're either going to be 0, -1, or +1, and then we return those values. So move direction has a dx property. Think of this like the player's position. This is the direction that they want to go in, and this is how fast they're going to move in that direction. Now, I'm just going to head over to my whiteboard really quick because we're going to just talk really quickly about the relationship between position, speed, and time. I want to make sure that we are all on the same page. There is a equation of motion in physics that says the average velocity of an object or the average speed of an object is its distance divided by its time, how far it goes in some given time interval. So if I multiply both sides by time, time cancel, and I can say, hey, the distance an object travels is equal to its velocity times the time interval with which it's moving. Now, this distance is like our position, okay? So this is our position. This is player dot x. Okay, you can see it right here, player.x or player.y. Now, this velocity, this speed actually has 2 parts. Okay, it has the direction they're moving in and the size of the speed that they're moving. So here is the direction that we're moving in, and here is the size of the speed that we're moving in. The thing that we're missing is time. We're not multiplying by our time interval. This is how fast we're moving, maybe like, 5 or 300 pixels per second, but how many seconds are we moving? So we have to multiply by some time interval, and that time interval is our dt. How many seconds have elapsed since our last frame? So let's take this line right here, and let's take our speed and multiply by dt. We passed it into the function, so now this function can work with dt. And that should fix our movement system. Take it from frame-based movement to time-based. Let's see. Hey, our movement system is now fully operational. I'm back in business. All right, so I can move all around now. But I still have a broken weapon firing system. So the heat system's good. Movement system is good. Let's check mission number 4. Is this going to be about our bullet system? It is. So mission number 4 puts us in update bullets, where we now have access to our time. It looks like we have to do the exact same thing here. We're going to apply delta time to our bullet movement now. So our bullet's position is going to equal the bullet's horizontal velocity. This actually has the You can think of this as having like the direction and the size of the speed built into it. So they're baked in together in one. And so I'm just going to multiply that by dt. And I'm going to multiply this by dt. So now we are setting the new positions of our bullets in the x and y direction correctly. All right, so now our bullet system should be back. Oh, awesome. It's like we're right back where we started at the end of our last lesson, right? Everything is working. Heat, movement, and bullets. But now it's working in a time-based system instead of a frame-based system. And that is super, super important for us for consistency of gameplay. All right, and we can overheat, and we scale back down, and then we get our firing back. This is great. This is really wonderful. Now that time is working, let's use time to create a difficulty ramp for us. So as we play our game, it's going to get harder and harder and harder. That's what we want. We want our game to get more challenging the longer we're playing it for. So we're implementing a new system here, a ramp system. And so what we'll do is we'll set some ramp constants. And this is going to put us in the student edit zone, where we can change these values for our system to see how they affect our gameplay. Now, let's look at what we got to work with. We have ramp time seconds. All right, so this variable here is going to determine how long it takes for the game to hit its maximum difficulty. Right now, our game is going to hit its maximum difficulty after 25 seconds. That's a little too quick for me, okay? I want my maximum difficulty to show up after about a minute of playing. So that's going to be 60 seconds for me. And now if you look, we have a bunch of variables that are sort of tied together. Enemy spawn seconds start, enemy spawn seconds end. So at the start of our game, how many seconds do I want to wait before I spawn an enemy? I'm going to do 1.20 seconds. And then at our maximum difficulty, so after 60 seconds has gone by, at our maximum difficulty, how many seconds do I want to wait for spawning? Well, I'm going to make it a lot smaller so they spawn faster. I'm going to do 0.45 seconds. All right, next I have enemy speed multiplier at the start and at the end. So at the beginning of the game, my speed multiplier is just going to be 1. Our enemies are going to move with a given speed. And by the end of the game, when we're at our maximum difficulty, 60 seconds later, whatever their speed is, I'm going to multiply it by 1.85. So imagine if the speed of our enemy, when we spawned them at the start of the game, was like, 125 pixels per second. When they're at the end of the game, if I were to spawn them at that speed, I'd multiply that by 1.85. They'd actually be moving at 231 pixels per second. So they're going to move faster. And then we have some variables that are going to control how many enemies we actually spawn when it is time to spawn enemies. So when we start our game, I'm only going to spawn 1 enemy each time. But by the end of the game, every time we go to spawn enemies, I'm going to spawn, let's say 3 enemies. So we'll spawn them in waves. So when we hit 60 seconds, instead of just spawning 1 enemy, we'll spawn 3 enemies. And so our ramp is going to control how we go from these starting easy values all the way to these sort of more difficult ending values. Mission number 5 is in the books. So now let's go implement this ramp. And so we have a function called update ramp values where we see mission 6 and mission number 7. Mission 6 asks us to define the difficulty ramp value, and we're going to normalize it between 0 and 1 over time. All right, I think we got to go back to the whiteboard just for a little bit here to do some math. So I'm going to pull up my whiteboard. I know we got to do math because I don't want to just tell you guys lines of code. I don't want you just writing lines. I want you understanding lines. So what we're going to do is we are going to create a ramp. So we're going to say, hey, our ramp is going to be some number between 0 and 1. Okay, so our ramp is going to be some number between 0 and 1, and it is going to control the difficulty of our game. So I don't know, let's just say it's going to control, let's say it's going to control, I don't know, let's do our spawn interval. Well, no, let's do our speed multiplier. So we'll say it's going to control our speed multiplier. And I know that when we start, our speed multiplier is going to start at 1, and then it's going to go to, I think we said 1.85. So the way you can think about this is imagine a graph, zoop, zoop, and on the x-axis, we start here at 0, and we end at 1. This is our ramp, okay, from 0 to 1. On the y-axis, we're going to put a value that we will control via our ramp. So on the y-axis here, I'm going to put my speed multiplier. It's going to start at 1, and it's going to end at 1.85. Now, we know 2 points here. We know the starting point of our speed multiplier. So when we start, we're here at 0. And when we end, our ramp is going to be 1 at the end. Our speed multiplier should be 1.85. Okay, bloop, all the way over here. Now, imagine I took that starting point and that ending point and I drew a line between them. That line is going to control the value of the speed multiplier. So if my ramp is 0, I'm at 1. If my ramp is at 1, I'm at 1.85. But let's imagine, what would it be if my ramp value was right in the middle at 0.5? Well, I don't know. How would we figure that out? Let's do 1.85 minus 1. So divided by 2. So I would be at and when my ramp is 0.5, this y value is going to be, what was it, 1.425. So we would say, hey, the speed multiplier is 1.425. If the ramp got bigger, if the ramp value got bigger, so instead of being 0.5, if it was like all the way over here at like 0.8, well, now when we look, the speed multiplier is going to be greater. The speed multiplier might be like 1.72. And if the ramp were small, right, it starts at 0, let's say just increase to like, I don't know, 0.3. Well, now the speed multiplier is going to be smaller. Maybe it's only going to be like 1.26. So where you are on the ramp, as the ramp increases, the speed multiplier values increase based off of this linear line. And that line, drawing a line from your starting point to your ending point and calculating your values based off of that, is known as linear interpolation. And we can perform this using a function called lerp. So we're going to build our ramp here first, some value between 0 and 1, and then we're going to use that ramp to do some linear interpolation. So let's build our ramp, a value between 0 and 1. We are going to create a variable called ramp. And if we look, let's just go see, do we have this variable? I'm going to go up to my gameplay variable section. So here are all of my gameplay variables. I have a ramp variable, which is currently set to 0. I have the enemy spawn interval variable, enemy speed multiplier, and enemies per spawn variable. These are all things that are going to be controlled by our ramp system. Didn't we define constants for all these? Yeah, look, enemy spawn per seconds, enemy speed multiplier, enemies per start. Those are our ramp constants. And then these are what they're going to target as we change them throughout the game. So when we go to reset game to defaults, right? We start our game, we call reset game to defaults. What are we doing with those variables? Well, ramp is getting set back to 0, and then we're starting all of those variables at their start value. Then we need to increase them as we play our game. As our game goes on and we play the game longer and longer and longer, the ramp needs to get bigger and bigger and bigger, and those values need to work their way towards the ending version of those variables. So our ramp, let's assign or build our ramp. So our ramp, let's see, we want it to be based off of how long we've been playing. So I have runtime seconds, which is keeping track of how long I've played, and then I'm going to divide that by ramp time seconds. Remember, ramp time seconds is the amount of time it is going to take for our game to reach its maximum difficulty. So 60 seconds. So when we start our game, runtime seconds is 0. 0 divided by 60 is 0. It puts me right here at the starting point of my ramp. If I play the game for 30 seconds, 30 divided by 60 is 0.5. Zoop. It puts me right here on my ramp. So my speed multiplier would be 1.425 seconds. And when I hit 60 seconds of playing my game, runtime seconds is 60 divided by 60 is 1, and we would be at our maximum difficulty for a speed multiplier of 1.85. This is going to work awesome. There's just one big problem. If I survive and then runtime seconds gets to be like 61 or 62 or 70 or 80 seconds, 80 divided by 60 is greater than 1. It's going to put me over here. I don't have anything defined for that. So this is a problem. So what we're going to do is we are going to actually call the constrain function, and we're going to constrain this value. We're going to constrain this value and say, hey, this value needs to be between 0 and 1, because that's what we defined our ramp as, between 0 and 1. Now that we have that ramp, let's look at mission number 7. It says we'll use lerp, or linear interpolation, to scale some of our values. So look, we're already using lerp to scale our speed multiplier. So we're saying, hey, use linear interpolation. We're going to provide the starting value, so 1, the ending value, 1.85, and then we're going to give you where we want you to go on that line between those 2 points. And that where we want to go is given by our ramp value, which we just defined. So right, here's enemy speed multiplier. Here's your starting point, enemy speed multiplier start. Here's your ending point, enemy speed multiplier end. And then the ramp value is going to be where we are on our x-axis. So if I pass in, say, like 0.6, beep, we're going to go up here, read the line, and we will set the enemy speed multiplier accordingly. So that is already in place for our speed multiplier and our enemies per spawn. We need to add it for our, let's see, spawn interval. So I'm going to target that variable that we had, enemy spawn interval, tab for autocomplete, is equal to, well, we are going to use linear interpolation, or lerp. So we're going to call the lerp function, and we have to pass in the starting value of this. So our starting value of that line is our constant enemy spawn seconds start. So it's going to be the second one here, because this is in alphabetical order. This is enemy spawn seconds end. This is enemy spawn seconds start, tab to autocomplete. So that's the first point on our line. Our final point on our line is going to be enemy spawn seconds end. So that's here, tab to autocomplete. And then that creates the line for us. And where do we need to be on the line? Well, it's all dependent on that value from 0 to 1 called ramp. Awesome. So now our ramp is in place. Let's take a look. Let's scale this. All right, so the DT system is working, movement's working, heat's working, firing is working. I have a ramp system in place that's going to control the difficulty of our game. We're going to spawn enemies faster. There are going to be more enemies as we spawn them. They're going to be moving faster. Of course, I have 0 enemies to check this. How do we prove this, right? There is no enemy system. We have just built a system with which we can put enemies into, but we don't have enemies to put into this system yet. So let's go to mission number 8, our final mission, mission 8. So we want a way to visually see these values. And if we look here, mission 8 puts us in our draw HUD function. It says we are going to display our ramp, display a ramp readout, show progression clearly in the HUD. And if you look right below here, I have a function called display ramp readout. It looks like I create a bunch of text where I show the ramp, our spawn interval, our speed multiplier, and our spawn number. This is like a debugging function. So I am going to call that function, draw ramp readout. Let's call that function and show all of those values to the screen. So if I refresh my page, I now get my ramp right here. So the ramp is currently at 0. My spawn interval is at 1.2, which is what we started at. My speed multiplier starts at 1, and my spawn number starts at 1. As I press enter, my time interval is going to go up. And because of that, the ramp is going up, right? Because the ramp is defined as what? That time divided by... Yeah, the ramp is that time divided by our ramp time per second. So once we hit 60 seconds, this ramp should be at 100%. And so you can see as we play our game, the spawn interval is going to go down. So our enemies are going to be spawning faster and faster and faster. Right now, enemies will spawn every second, every 0.98 seconds, every 0.96 seconds. Right now, we're going to be spawning 2 enemies each time, and their speed multiplier is going to be at 1.35. So as we spawn them, they're going to be moving faster and faster and faster. So right now, we just hit like 50%, and that was at 30 seconds. So that sort of tracks right there. I'm going to pause the video, and we'll see if it hits 100% maximum difficulty at 60 seconds. Okay, so right now our system uptime is at like 55 seconds, where our ramp is at 90%. So when we hit 60 seconds, we should be at maximum difficulty. Boom, right there. Our spawn interval stops at every 0.45 seconds. Our speed multiplier is there, and we are now spawning 3 enemies every time we spawn. This is awesome. This is really great. So we have taken a frame-based game that was going to be inconsistent on different machines and made it consistent by switching to a time-based system. Keeping track of time allowed us to build a difficulty ramp. And on this difficulty ramp, which scales difficulty as we play longer and longer and longer until we reach 60 seconds, our time for maximum difficulty, we are going to control an enemy system. The enemy system is not in place yet. Okay, but we can control it. We can make our enemies spawn faster, move faster, and spawn in larger numbers. And in our next video, we will add that system of pressure by actually creating our enemies and letting our ramp control most of that work for us. So I'll see you in that next video.